Hey everyone, welcome back to another AlgoSkills LeetCode tutorial video. In this video, we're going over LeetCode 2716 minimum string length. So we're going to read through the question, break it down, then we're going to move over to the whiteboard where we're going to kind of visualize how we're going to solve the problem, and then we're going to come back to LeetCode and write some code. So before we get into that, let me just say, if you want to land that dream job, you want to kind of ace those software engineer interviews, I'd highly recommend checking out our course AlgoSkills. Link will be at the top of the description. I'm an ex-Amazon software engineer. I've done it before. I teach you those exact skills to land that dream job. So if you want to do that, I'd highly recommend checking out AlgoSkills, link below. So let's get into the question. Let's give it a read. Given a zero indexed string S, repeatedly perform the following operation any number of times. Okay, that's pretty straightforward. So the operation is we choose an index in the string and let C be the character in that position. Then we delete the closest occurrence of the character C to the left of I, if any, and the closest occurrence of character C to the right of I. Okay, so basically from that, we pick just a we pick a position in the string, and then to the left of it, we delete the closest occurrence of that character. To the right of it, we delete the closest occurrence of that character. That's pretty straightforward. And so we're trying to minimize the length of S by performing this operation any number of times. And then we return the length of the minimized string. So you have some examples. I'm going to go over them on the whiteboard because it's probably going to be a bit clearer. So this is our first example. We have AABC, and our goal is to get this string down to the shortest length that we can using this operation. So since we're deleting characters to the left and the right, obviously we're going to go for A first because there's only one instance of this B, there's only one instance of this C, but we have multiple of this A, so we can definitely delete some characters. And because we're deleting to the left and to the right, let's pick this one right here in the middle. So the closest occurrence of A to the left is this A right here, and the closest occurrence of A to the right is this A right here. So now we have A, B, C. And so from there, we can't really delete anything else, because if we select A, okay, where's the closest A to the left? Nothing. Closest A to the right? Nothing again. Same goes with B and C. So this is our output. This isn't our output. This is the minimized string. And then our output is the length of this, which is 3. Okay? So that's our result for that. That's how we get there. Let's take another example. So this time let's look at the second example that LeetCode provided, which is C, B, B, D. Okay? So we have this example. Again, we don't want to select C or D because there's only one instance of them. We're going to select one of the B's. It doesn't actually matter which one we select. So if we select this one here, we'll delete this character. If we select this one here, we'll delete this character. So we'll just select this, delete let's search to the left. Let's do it properly. Search to the left. There's no B's here. Search to the right. Okay, we found a B, deleted it. And then this is going to give our resulting string of C, B, D. And now we have only one instance of each of these characters, and we can't do anything else. So this is our minimized string. Again, same result, 3, which is the length of this. So that's how it works. And it might seem a little complicated because you might be thinking, how am I gonna, write the code to actually kind of do these operations? But let's see if we can identify any patterns here. See if we can kind of simplify this problem. So let's start with let's just kind of work through. So when we have an example of A, B, C, right? So one of every character, you'll know from the first example that when we get here, we can't do anything. So when we have one instance of each character, so we have one A, the smallest we can get it down to is 1. We can't get it any smaller. We have 1B, it's going to always be 1B. We have 1C, it's always going to be 1C. So when we have one instance of a character, the result is always going to be, the minimized string is always only going to contain one of that character. Let's increase this. Let's take a look at 2Bs. So we have 2 characters, right? And you'll know from the previous example, when we have 2 characters, we can select this one and delete it. And delete this one, or we can select this one and delete this one. So we had two B's, right? We deleted one of them, and we were left with one B. Okay, so let's check 3 now. So we have 3 B's, A, B, B, C. Let's select this middle character here. Delete the first B to the left, so this one. Delete the first B to the right, so this one. So we had 3 B's originally, and now we have 1. And so there's a bit of a pattern showing here. We had 1 B, it went down to 1. We had 2 B's, it went down to 1. We had 3 B's, went down to 1. Let's see if this pattern continues. Let's go to 4 B's. A, B, 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 C. Okay, so let's select one of these middle ones so we can delete the most characters. So I'll select this one here. We delete this, and we delete this. And then now we're left with A, B, B, C. And we can select the same character again and delete this one here. And you'll also notice when we were at this A, B, B, C, that's literally this problem here, A, B, B, C. And we know from this problem, when we have 2 of a character, it produces 1. So we've essentially brought this down from 4 characters to 2, and then we've already covered the 2 scenario, which is just that it goes down to 1. So we know that now when we have 4, it goes down to 1. So there's a pretty clear pattern showing up here. No matter how many characters we have, it's always going to result in the minimized string. There's always going to be 1 of it, right? So we can have a million A's, a million B's, a million C's, and it's going to come to A, B, C still. It's still going to result in this because we can continue to reduce it. So this makes the problem considerably easier. Now it's really, really easy because we just need to find out how many distinct characters there are in the string, and that's literally the result. So if you've used hash sets before, or we can just do that. We can just keep keep adding these characters. I will go through the string, add every character to the hash set, and then return the length in the hash set because there's no duplicates. So it's going to handle that for us. But that's going to be the approach. So we've reduced this problem from, this complex problem of, okay, we have these operations, we need to minimize the string, to let's just count how many unique characters are in the string. So let's go over to LeetCode and let's code that problem. So I'm going to start with that set I was talking about. So I'm going to create a set called unique characters. And then I'm going to go through every character in the string. So for char in string, I'm going to add the character to our set. So unique characters dot add char. And so once we've gone through the entire string, the unique character set should have every single unique character that is in the string S. And so now I just need to return the length of unique characters. So the length of this set, and this should give us the desired result. So I'm going to submit this. Let's see if it's running correctly, if I've done any mistakes. So that's all fine. This is a very performant solution. O of n runtime. We just go through every character in the string. We do need a little bit of space because we need enough space to store every unique character. And so some people, just the record, if you really want to minimize this, say you're looking at the solutions on LeetCode, you might see somewhere it's even shorter and you might go, why didn't you share that? Just for the sake of full kind of showing all the, how we can optimize it even further, even though I don't know if I'd write this in an interview, because I feel like the code I showed before is a lot clearer and it kind of shows your understanding of algorithms a lot better. But we can also, if we just want to minimize it, do it in one line, we can just actually return the length of the set of S. So this here, when we do set of the string, it basically does this for us. It goes through every character in S and adds it to the string, and then we have our length of that. So this should also work fine. And as you can see, that also runs fine. So that's kind of how we code this solution. I really hope this video was helpful. I hope it was clear. If you did like it, I would appreciate it if you would like and subscribe. So thank you guys so much for watching. Have a good one.